Thank you very much. We're from Icon, and we're here to talk to you about instant payments. I'm Richard Deere, Business Development Director, and with me is Tom Hay, our Head of Payments.
Hello.
Now, instant payments present a new set of challenges for banks and PSPs. These challenges include how to easily configure and enable new products and services, how to get fast go-to-market, and how to meet the non-functional requirements, such as scalability and highly performant transaction processing. We think these challenges make instant payments a great use case for the deployment of open source frameworks. In fact, we believe that unless banks and PSPs are using the same kind of technology as the market disruptors and internet scale providers out there, how are they able to compete? To that extent, what we've done is codify Icon's many years of experience with instant payments within a new software product, the Instant Payments Framework, or IPF, and Tom will demonstrate that to you now. Tom.
Thank you, Richard. What you can see here on the dashboard is IPF, processing instant payments quickly and reliably. And that's the end goal that lots of banks want to get to as instant payments rolls across the world. What I want to do today is to take you behind the scenes to show you how IPF can help banks get to that point quickly and give them the flexibility that they need now and in the future. So let me start by showing our model. This is our starting point, and what we do is we capture the processing logic for every type of payment in one of these UML models. We're using an open source modeling tool, and what you can see is an SCT instant payment. The reason that we have taken this modeling approach is to give ultimate flexibility and to give power to the users. Every bank is different. Every bank requires different processing of their payments, and the modeling tool allows the banks to tailor IPF to meet their exact requirements rather than coming back to the vendor and asking for change requests. If I zoom in, you'll be able to see that the model is expressed in plain English, phrases like posting payment to account. We've done this deliberately to allow the business to understand what is going on at the analysis and design stage and to work hand in glove with IT. That way, you can get the design right first time. And that's important because when you press the button, IPF is going to generate from this model, it will generate executable code, which you can then deploy into our execution engine. So this enables you to meet both the needs of today, but it also gives you the power to meet the unknown needs of tomorrow. Payments is changing rapidly. There are new flows that will be required, new products, new services. You can design the new flow in the design front end and rapidly deploy using IPF's microservices architecture without disrupting the existing payment flows. So much for flexibility. Let me also show how this will get you to market quicker, because we're not just giving you a toolbox and you don't start with an empty sheet. We have codified our knowledge in the form of what we call scheme packs. So for each of the instant payment schemes that we support, which are global, we provide the message transformation and the processing logic that is required for every message type within that particular scheme. Basing your deployment on this enables you to leverage our extensive experience of designing and deploying this kind of system with banks all around the world. As well as the message flows, we also provide a comprehensive library of payment business functions. So the business is able to use these pre-validated, pre-tested building blocks, again, accelerating the journey to market for the system. Design and analysis is only one part of the delivery process, though. Testing is often the most time-consuming element in the project. And so we have also provided an automated functional test framework. What you can see on the right-hand side is our English-like scripting language. This is extensible. And again, the objective, just as with the UML modeling, is to allow the business to cooperate and work hand in glove with IT to make sure that their requirements are accurately met first time through. These scripts are built up for each area of the system, and on the left-hand side, you can see the full suite of tests. These can be run as a suite of regression tests at the click of a button, meaning that your regression testing is executed in minutes rather than the days or weeks that it would take if you were doing this manually. So again, we're speeding the bank's journey to market. I'd like to come back now to the dashboard. What you can see on the left-hand side is 4 servers. Each of them is processing instant payments in parallel. The reason that we have chosen this distributed architecture is that it gives multiple benefits. It's highly scalable because as the load that you need to process increases, you simply add servers, and you can add as many as you need to process hundreds or thousands of transactions per second, one of the benefits of the internet technologies that we are using. It provides high availability because if any one of those servers fails, the remaining servers can simply pick up the load and continue running. And it's suitable for active deployment across data centers. So even in the case of a data center failure, your payments service will continue running unaffected. This graph shows you how fast IPF is processing payments. You can hardly see this at the bottom of the screen, but it's less than 20 milliseconds per payment. So fast to market, fast to execute. Richard.
Thank you very much, Tom. So we've been able to show how IPF meets just some of the challenges with instant payments. We'd love to talk to you more about the other challenges that IPF meets. So please come by the stand later today and have a conversation, and don't forget to vote for us as well. Thank you very much.